like to just talk so that we're all in agreement that when we look at these, we're talking about either a +7 or a -7. Emily, thank you. Both of these, the term, they both have a K, and we're just talking about this is a 3 and a 3, a 5 and a 5, 1 and a 1. But the pattern is we have a positive and a negative. And then when we have our answer, what happens? Okay. And everybody is clear with that. There is no middle term. This has a name. Anybody know the name for this particular binomial? Anybody remember this? Zach?
Actually, I was just going to say ax squared minus c, but I don't know.
Okay, you're very close, Daniel.
Do the perfect square?
It's the what?
Do the perfect square?
It has to do with the perfect square. There's a word there.
That family.
Okay, it's the difference of perfect squares. Doesn't it make sense? And I will use that expression with you again, again, and again, and again. And I will say, is that the difference of perfect squares? Because difference means what? You're subtracting. And is this a perfect square? And this is a perfect square. So please make sure that you have that on your notes, that this is the difference of perfect squares. Okay, so that is the difference of perfect squares. Okay? And in this case, let's look at group B. And in group B, we saw again that the numbers were the same. +7, and we're dealing with a 7 and a 7, a 3 and a 3, 5, 5, 1, 1. The first terms are the same. And this time the pattern is what? They're both positive. Okay? And when we multiplied it out, our answer was what? Both positive. Okay? Now, if you remember the first day that we started taking notes, I can find my folder. Do you remember the first thing that I asked you to look for was, is it a perfect square? Sure, look, that was my first question. Is it a perfect square? Because that's going to be really important to you now. Now that you know about these patterns, you need to get into the habit of, is it a perfect square? And I'll show you why in a second. Okay, so does anybody, this is called, this also has a special name, and this is called, and I'm going to just abbreviate, this is called a perfect square trinomial. Okay, because the first term is a square number, and the last term is a square number. So it's called a perfect square trinomial. Okay? And the last one is a little bit different than the this one in that both the signs were what?
Negative.
Both of these are negative,
Wait,
right?
wouldn't that be a positive 49 if it's multiplied?
Yes, you're right, you're right. It is a negative and a negative, and this is a positive 49. So the first term is always going to be a negative, and then the second one will always be a positive, because we know that a negative times a negative will give me that positive 49. Okay? There's one other little bit of information that I'm going to show you. The middle term, and I think Cassie found it, the middle term is always what?
There, you did.
Double.
The sun.
It's what?
It's double.
It's always doubled. So the formula for the middle term is going to be 2a. So if a is, whoops, I can't see that. It's always twice your first term. Okay, so it's 2, and what is the numerical coefficient here? 1. So it's 2 times 1 is 2, and I knew that I was going to use 7, so 2 times 7 is 14.
Wouldn't that be your,
Yeah,
why is
that's
that
not the
A?
first
That's not the
term.
first term.
It's not the first, I don't know why it's 2a, I don't remember it. X squared,
It's like, it's the second.
well it is, it's the factor of a. If this was a, isn't x the
I thought
a
A
term?
would be like where that last one, A would be the 3, not the 1. Because isn't it usually,
Isn't A like X? Not
Yes,
Yeah.
it's the coefficient next to
A.
a.
Two
But then
A.
that
So
7 would
2a
be
is,
But it's 2x, so how do we get?
No, what is the numerical coefficient of x?
One.
1. So 2 times 1 is 2,
But
and then you're multiplying it times the last term of the binomial.
Okay,
So
so it's
it's
2a
times-
Times that 7, yes, 2, all right. All right, so anybody have any questions? Okay, flip your paper over. Okay, hold on, I just lost one.
factor them all.
All right, so let's start looking at number 1. Okay, so number 1, what do you know? Does this have a name?
It's a difference of perfect squares.
So what are I know that's going to be a 3. Are my signs going to be the same or different or what?
Different.
It's going to be a x plus 3, x minus 3. So at this point, you should be able to look at these, and then determine what they are. So if they are not a perfect square, can we use this method?
Yeah.
That we're learning right now. No, this only works if the numbers are perfect squares. Okay, so let's look at number 4.
I don't
Okay.
understand what method that is.
Okay, so right now I'm taking you backwards. Is this a square number? Is the first and the last term a square number? So what am I going to have? 2, and they're both positive. So going to be 2 plus what? 3 times 2 plus 3. The factors of this.
Yeah.
Yes, sorry, 2x plus 3, 2x plus 3. Okay, what about number 7? 9x squared minus 4, is that the difference of perfect squares?
Yes.
Okay, so what are you gonna have?
3x plus
2, 3x minus 2, because I know that I don't have a middle term. Okay, now, could we do the area model if you didn't like this? And you totally spaced out, oh, this is a difference of perfect squares? Could I do the method that I've taught you previously? Yes. Okay, but isn't this is just a shortcut. So if you know the shortcut, you can use it. If not, you can do the method that we've done before.
What do you do for like number 13?
Okay, number 13. Anybody have an idea? Jess,
You divide them by 3. So
why did you divide by 3?
Because
GCF.
Greatest common factor.
GCF, greatest common factor, is going to be a 3. So if I pull out the 3, what do I have?
N squared minus 1.
Is this the difference of perfect squares?
Yes.
Okay, so I know that it's going to be what? N
-1
minus 1,
and plus 1.
N plus 1. Okay, is that handy? Do you like knowing this or not? Oh, you don't sound overjoyed. Okay, so these are the ones that you should be able to do mentally. Okay, if you find that challenging, you don't necessarily have to do them mentally. Yes.
How would you do? Could you do one with
Yeah, but
two
because the
and
coefficient, you have to double this.
This?
So you're 2 times 2
Okay,
is 4.
so if I did the area model, what's gonna go there? 3n squared, what goes over here? What? And minus 3. And then what's gonna go in here? What are the factors of a -3 that would give me a 0?
So good. I think you mean -9.
Let me see, how would I do this? Well, let's just leave it like that for the moment, and what I have 3n, and this is n. And what will be here that will give me this? I'm not sure, actually. This, oh, you're right, it has to be 9n squared. So this has to be 9n squared. So what are the factors of 9n that, when combined, will give me a 0?
Wait, would it be negative 9, so it'd be
Negative
negative 3 and 3?
3 and a
Positive.
positive 3,
And
n, because a negative 3n and a positive 3n will give me a negative 9n squared.
Yeah.
Okay, and so I know that they have to combine.